I'm going to go to my Canvas web page and show you what need to be done before the test on Friday.
Before Friday?
Yeah.
Okay.
I'm going to send the passcode for test 4. You can take it from 9 a.m. to 10 p.m. Okay?
We could take what from 9 a.m. to 10 p.m.?
Test 1
Test
on
one, okay.
right. Let me share my web page. Can you see my course web page now?
Yes, sir.
If you look on the side, you need to watch Zoom meetings. If you have, there are going to be 5 Zoom meetings. This is right here is the test 1 and 2. When you're taking it, you go there and click on it. There are 2 quizzes, chapter 1 and chapter 2 quiz. To take them, you go to the module 1. If you scroll down, right here is the quiz number 1, chapter 1. And after chapter 2 details, this is the quiz 2. You can go there and click on to take that one. Ideally, you need to take the 2 quiz. Ideally, you have to take the quiz 1 and quiz 2 before taking the test 1. People don't follow what I say.
Excuse me.
Yeah.
So, okay, have quiz 1 and quiz 2 done, and test 1 is due by this Friday, right?
Yeah.
Okay.
You can practice on quiz 1 and 2. You can complete it after you taken the test. All right?
All right.
All right. Is there any question about how to access quiz 1 and quiz 2?
No, sir.
Okay. I'm going to share, what I'm going to do is, there are a few items on the chapter 2. I'm going to quickly finish valence shell, number of valence shell electrons, and the periodic properties of elements, such as ionization energy, atomic size and ionization energy. I'm going to first go to, can you see my chapter 2 on atoms slide page?
Yes.
Okay. We have to finish last 2 sections, electron configuration and periodic table. We go over how to get electron configuration using periodic table. Now is the time to know what is valence shell of an atom is, atom of an element, and also how many valence shell electrons are there. This is important because valence shell electrons tell you how many bonds are going to be formed between elements. Then we also going to look at periodic properties such as atomic size and ionization energy. Okay, I'm going to go down to where I left off. That's what we're going to talk about. Valence shell is the outermost. Let me get this going. Outermost incomplete shell. There are shells around the atom. Each shell has an n value. The shell closest to the nucleus is called n is equal to 1. That's like orbit of a planet, but it's different. So electrons are arrangement of outermost shell is the most important thing for chemistry. Therefore, we deal with that some more. Valence electrons. Valence electrons are shown as a Lewis dot structure. Let me show you how you get a Lewis dot structure for element. There are 8 groups here. 1A. These are the main group elements. Alkali metal, alkaline earth metal. Then the taller columns with the number and the letter A's. So let's look at hydrogen. Hydrogen has 1 valence electron because from the left, hydrogen is the first one. You count the number of places on the tall columns from left to right. Hydrogen has 1 electron. Therefore, valence shell Lewis dot structure is H with a 1 dot. 1 dot means hydrogen can make a bond with another lone pair of electron on another atom. Therefore, it makes 1 bond. In a group like alkali metal 1A, every element has same dot structure, Lewis dot structure. Therefore, they have similar chemical properties. Beryllium is the alkali metal, first alkali metal, and the magnesium is the second. Then you have magnesium, calcium, barium, etc. on the second group. You have 2 electrons because in the periodic table, beryllium is found in this count in the columns, first column, second column. There are beryllium and magnesium is in the second column. Therefore, there are 2 electrons. Similar to that, boron, which is the next taller column in the periodic table, when you move from left to right, there are 3 blocks. Therefore, 3 valence electrons. For example, boron makes 3 bonds. That's the idea. Valence shell electronic configuration. After getting that, Lewis dot structure is the simplest way to explain the bond. Carbon has 4 electrons. From where the carbon is, you have to move 4 blocks from the left. Silicon also has 4 electrons. Nitrogen has 5 electrons. Can you see 1A, how many lone pairs are there? How many electrons are there? 1 electron. 2A, how many valence electrons are there? 2. 3A, how many valence electron? 3. 4. 4 valence electron. 5 valence electron. Then you go to 6, which is the oxygen and sulfur group. They have 6 electrons. Now, after filling up in the carbon, after filling the 4 electrons to the corners, you have to pair up. Right here it is. Extra electron is paired up. So you go pairing up another electron on the other side, on the oxygen. So 7 electrons. There are 7 electrons. Therefore, group number gives you directly. This is noble gases. They have, except helium, they have octet of electrons. You say 8 electrons? 8 here. Therefore, it is very simple. Once you get the electronic configuration, look into the valence shell. Orbitals with highest n number, they are added up to give the number of valence electrons. Chemical properties of element depend on the number of electrons in the valence shell. Valence shell is the outermost shell with highest value of shell number. The electrons in the valence shell are called valence electrons. Beryllium has 2, is in the second column. Valence shell is this, not that one. Highest N is 2. How many valence shell? 2 valence electrons. Shell number is 2. That's the valence shell is 2s2. There are 2 electrons right here. So similarly, chlorine has highest N value, or outermost shell is 3p, 3s2. There are 7 valence electrons. From the electron configuration, you should be able to get the number of valence electrons. We go on over this. First period, first group 1A alkali metal has 1s1. Now, if you look at this, all the atoms of elements in a group have same ns1 here. N could be any group period value, 1, 2, 3, 4, 5. Therefore, similar chemical properties. That's the idea. 2A has 2 electrons. All the 2A's have 2 electrons. 3A has 3 electrons. 4A has 4 electrons. Therefore, carbon has 4 electrons. Lewis dot symbol is this. We go now in the previous slide. This is kind of summarizing all the groups. One thing you notice is in a particular group, the valence shell structure is the same. For halogen, NS2, NP5. This is NS. Do you have any question about valence shell?
No, sir.
All right.
No, sir.
Elements in the same group have similar electronic configuration, therefore similar chemical reaction. Elements in the same group have the same number of valence electrons. The main groups, which have a big letter A, number followed by big letter A, number of valence electrons are same as the period number, group number, group number. Except for helium, which has only 2 electrons, noble gases have 8, other noble gases have 8 valence electrons. Let's answer this question. Valence electron of atom, which of the following is the correct Lewis structure for nitrogen? Now, nitrogen, if you go to the periodic table, 1s, 2s2, 2p3. These are the 4 answers. This is the valence shell. How many electrons are there? 3 plus 2 is 5. This is 2. This is 3. There need to be 5 electrons. Therefore, this is not the correct one. This has 6. This has 7. This one is the only one with 5. Do you see how I got the answer? D. All right.
Yeah.
Must be piggybacking the IP address from another location.
Do you got it?
Yes, sir.
Okay. For oxygen, this ABC I have outlined here. Oxygen has 1s2, 2s2, 2p4. Therefore, it has 6 valence electrons.
So it'll be A, right?
Right. This is wrong. Why that is wrong?
Because 2 of the dots are together and 2 are supposed to be
Yeah,
separate.
normally you distribute the dots around the atom. Okay, this is wrong. That's 7. This is only 5. Therefore, A is the correct answer.
Would it be? Isn't it the atomic number?
Hey, Oscar, can you mute your... Please turn off your microphone if you're not asking questions. Okay. Which of the following determines the number of valence electrons in an atom if a main group element? We go on our column number. 1A. How many valence electrons? 1A. 1. 2A. 2 electrons. 3A. 3 electrons. 4A. 4 electrons. Therefore, it's not the atomic weight or atomic number. It's the group number. See the correct answer. Which of the statement is true of the electron configuration of family in the periodic table. Number is not equal to the group number. That's not a true statement. Number of valence electrons is equal to the group number. That's correct. The valence electrons are always paired. No, it depends on number of it. The valence electrons are never paired. That's not true either. It depends on. So answer is B. How many of you got the idea now how to use the electronic configuration and get the Lewis dot structure?
Yes, sir.
All right. Now we're going to look at periodic properties of elements such as atomic size and the ionization energy. I'm going to focus on those two. As we have seen, the periodic table was constructed based on the trend of periodicity of chemical properties. With an understanding of electron configuration, chemists realize the periodicity of chemical properties could be understood in terms of electronic configuration. That's the valence shell electron configuration. The periodic table works because the element is the same column or the group, vertical column, group or the family. Their outermost shell, valence shell electron configuration is the same. We look at two periodic properties, atomic size and ionization energy. Atom has a size depending on the atomic largest shell number. The atomic size increases with increasing N value for shell around the nucleus. Ionization energy is energy required to remove an electron from an atom. Atom loses the electron and form a cation. That energy also important in chemistry because to do chemical reactions, you have to remove the electron to another atom or share with another atom. It all depends on how easy to remove the electron or how hard to remove the electron. For metals, it's easy to remove the electron. Metals form cations. On the other hand, non-metals have high ionization energy. That means difficult to move electron from non-metals. Therefore, they gain electrons, form anions, negatively charged ions. So let's look at the atomic size first. Atomic size is expressed in terms of radius. Atom is a sphere. It's kind of a ball. The radius is the nucleus to the outermost shell of the atom. Radius of a fluorine atom is 99 picometers, right here. The carbon atom is, fluorine is 77. Radius is larger here, smaller here. Therefore, when you put the picture of two atoms touching each other, carbon is smaller because the radius is smaller here. Fluorine is bigger because the radius is larger. Why is that? The chlorine has larger size. Valence shell of the chlorine is 3s2, 3p6. This carbon is 2s2. 2p2, valence electronic configuration. The p orbital is the last electron added to here. The size of the 2p compared to 3p is larger. We said same atomic orbital. When the n number increases, it's bigger. Do you understand why the carbon is bigger atom than the chlorine atom? So therefore, we can compare, explain atomic sizes. There's a trend in the periodic table. Atomic radii, the radius from nucleus to the outermost shell. Do you see going down a group, atomic size increase? Going across a period, atomic size, I'm sorry, it's not here. That's not there. It's from the top, right to left, top to bottom. Normally, that trend is going down, is decreasing, increasing atomic size. When you're answering questions, the larger the n number, larger the atom. N number is 1 here. N number is 1, 2, 3, 4, 5. Therefore, cesium is bigger than lithium. So you can compare. These are metalloids, these are non-metals, these are transition metal, this is alkaline earth and S block, alkali metal and alkaline earth. The basic trend is going down a group, atomic size increase. On a period, it increased from right to left. So you should be able to answer question. Which type of subatomic particles does an atom gain or lose to become ion? Gain or lose protons? When ion is formed, what happens is electrons are either removed or making a cation, or gain electron, not protons or neutrons. Atom gain or loses electron. That's the correct answer. It depends on the atom. It doesn't make sense. See the correct answer. Which of the following elements have the largest atoms? Okay. How do you do this? If you look at periodic table, highest period here is, this is 3, N is equal to 3. N is equal to 3. Magnesium is N is equal to 3. Sodium is lithium sodium. N is equal to 3. They are all in the third period. Therefore, atomic size increases. This is the largest atomic size. Then this one, magnesium, then the aluminum. Because sodium, magnesium, aluminum is found in the, therefore it increases this way. The largest atom is C, sodium. Do you understand that question?
Yes, sir.
Their period being equal, then you look at the position of their group is equal, N is equal to 3. Therefore, there's no clear winner. If you have N is equal to 3, N is equal to 4, N is equal to 4 is the largest. In this case, all three has N is equal to 3. Therefore, you have to look at the periodic trend, how it varies. The atomic size increased from left to right to left in a period. What is the smallest atom? Same question. Smallest atom should be aluminum. Do you understand that? It increases from aluminum to sodium. Sodium is the biggest atom. Aluminum is the smallest atom. Which of them has the largest atom? This one is way down, rubidium. Potassium compared to potassium. Rubidium is the alkali metal. If you look at the periodic table, I have a periodic table. You look at the periodic table. You get a periodic table with your test. Rubidium is fourth period, fifth period. Potassium is, this is 5, this is 4, this is 3. The largest N number is 5. Therefore, answer should be rubidium.
Excuse me, sir.
Yeah.
So you said that we're going to be provided a periodic table in our test.
Yeah, you print out a periodic table. You are
Okay.
taking online. I don't have control about what you use.
Okay. What about the metric table for chapter 1? Do we have to print it out as well?
Yeah.
Okay.
Not the metric table, conversion table.
So yes, that. Yes.
Okay. I cannot be watching or you try to do best you can. Okay.
Okay.
Which of the elements in the smallest, having the smallest atom? Rubidium is 5. Potassium is right here, 3. Sodium is 2. This is lithium. This is sodium. 1, 2, 3, 4. This is 4. 1, 2, 3. This is 3. Which atom is the smallest? Sodium, right? That's how you got sodium. You look at the largest group number, N value. Which of the following elements has the largest atom? This is kind of tricky. Calcium is here. Calcium is N is equal to 4. Potassium is right there, N is equal to 3. Magnesium is right here, N is equal to 3. Sodium is right here, N is equal to 3. So largest atom is that. N is equal to 4 has a bigger. Therefore, this is bigger. I hope I got the answer. Let me do it again. I cannot see this one. Calcium is 1, 2, 3, 4, 5, 6. 4 is correct. Potassium is 3. That's correct. Magnesium is 3. Sodium is 3. This is the largest between these two. So between these sodium and potassium, potassium is the largest. Potassium is here. That's the calcium is here. Okay, now calcium, potassium and calcium, it increases this way. You see that. Therefore, potassium is larger than calcium. All right, that's how you got it. You have to look in the periodic table, this diagram, and figure that out. Which of the following elements have the smallest? Smallest is sodium, is 3. Magnesium is here. Therefore, it's between magnesium and sodium. Smallest is magnesium because sodium and magnesium. The smallest atom is atomic size increased this way. Therefore, magnesium would be the answer, C. Now you look into this table. Which of the following elements has the largest atom? Chlorine is here. Is the third period. Phosphorus is here. Is the third period. Carbon is second period. Sulfur is right here, third period. Largest atom, there are three of them, chlorine, phosphorus, sulfur. So chlorine is the smallest out of these three. You compare highest size of the N3. Chlorine is found on the right side, as smallest. Sulfur next. Answer should be phosphorus. Do you see how I got that? So smallest atom in this case is carbon. The smallest atom is this is third period. Carbon is second period. It should be the carbon. Smallest atom. I'm sorry. Smallest atom is need to be found on the right side. The chlorine is third period. Sulfur is third period. But this is found on the right side. When you move from period to the right, atomic size decrease. Therefore, chlorine is the answer. All right. We answered the question about atomic sizes. You look in the periodic table, figure out the group numbers, period numbers. Then you can work out which atom is bigger or smaller. Ionization energy is defined as energy required to remove outermost electron from an atom in the gaseous state. For example, lithium, when you provide energy added here, it loses the electron. Electrons are lost. Normally, non-metals will gain that, like chloride. So reactivity of lithium depends on how much energy is needed to be provided to remove electron. Normally, ionization energy in a group decreases going down. We're going to look into that. Ionization energy increases going across a period. In the periodic table, ionization energy going on top is opposite to the atomic size. That part is not there. It increases from bottom to top. Ionization energy is exactly opposite to the atomic sizes. In a period, this is first period, ionization energy increases. This is transition metals. Then after transition metals, that's group 1, 2, 3. This is 3D, 4 group 4. Transition metals goes into D orbitals. There's no change in the ionization energy in the transition metal. This is the trend. Ionization energy increase from bottom to top in a group. Ionization energy increases going on a period from left to right. What is the ionization energy of atom? What is the answer?
D.
Release when and energy release when. And normally, to ionize atom, energy is required. Required is different from release. Do you
Yes.
understand?
Yes, sir.
Between, that's not right. This is not added. Ionization energies to remove. This is the correct answer. Do you understand that? When atom loses an electron, the release is wrong. It's not gain of electron. That's the removing electron. So D is the correct answer. Which of the following is true? Comparing the two electrons that are different shells of atom. N number is different. Easier to remove is higher the shell number, easier to remove. Higher the shell number, easier to remove. That higher the shell number, closer to nucleus, higher the shell number, that's wrong. Higher the shell number is further away from the nucleus and easier to remove. This is wrong. It's not higher the shell number is not close. Higher the shell number, further away from the nucleus and easier to remove. That's the correct so far. The shell number further away from the nucleus and harder to remove is wrong. That part is wrong. That part is wrong. The correct answer is,
C.
yeah. Okay, that's how you got the idea. When potassium loses an electron to form potassium plus, which electrons? If you look at potassium, I look in the periodic table. Its valence shell is 4s1. Therefore, 4s1 is the one that is removed. One electron here is removed from. You look at the valence shell. It has only 4s1. Therefore, electron is removed from 4s. D is the correct answer. Now we have done the chapter 2. We go over a lot of problems during the introduction to the chapter 1 and 1-2 material. All right. So you can go back to where the sample tests are. Let me go back and show you where to find sample test. Okay? Can you see my web page?
Yes, sir.
In the module 1, last section is sample test for chapter 1 and 2. Now there are PDF files with all the answers and questions and answers. There are some videos also I recorded last time around. So I am going to go through some of the problems in the chapter 1 and chapter 2. All right. So you go there. For example, this has the answers. I think this one has written down all the answers. The second one for the chapter 1. Let me make it bigger. Can you see I have written down on all the answers to problems? All right.
Yes, sir.
Mainly in chapter 1, there are a lot of calculations. So if you have any questions about how do you got the answer, go back and look in this one. Normally you can do the first one without marked down answers. This second file shows the workout of all the problems. Do you see? So you can go after when you're preparing for the test. Just make sure you understand how to do calculation. You may not have to do everything. Okay, there are questions on answer to the question on chapter. I may have to go back. Hang on a second. Okay, I went back. That's the sample test right here. That's chapter 3, 4. This is a sample test 4. You can look into 1 and 2. You can find chapter 2 also here. Do you see this one? Let me click on that chapter 2 problems. These are without explaining. You can go back to, you can check out how you get the answers. Or go to module 1. For example, I have that's chapter 1. This one. there could be answers in it. Elements cannot be broken down. Atoms cannot, elements. Some of them are we already gone over. Which of the elements statement is true of nucleus of atom? Nucleus occupies a. Now we have a problem with this isotopic symbol. Xenon 180 is the xenon 118 is the name of the isotopic symbol. Knowing the xenon periodic table is atomic number is 54. We sometimes drop that subscript 54 because xenon gives that information from the periodic table. So therefore, easily obtained, we abbreviate xenon symbol to just 118 Xe. Contains how many neutrons? So if you subtract 54 from 118, is 64. So number of neutrons is 64. A minus C gives number of. All right. I am not going to sit down and have you watch with me. You can go to those questions, whatever you didn't understand, and look into video, the class videos, and answer to all the questions on chapter 1 and 2. All right. So I'm going to finish the class for today. I will send you the passcode for test 1. Check your email in the morning. The passcode would be sent in the night.
Okay, sir.
Do you have any questions?
Not really.
Just it's going to be easy
Okay.
if you follow the argument, follow how you work out.
Okay, sir.
Okay.
Okay, sir.
All right. I will be available. If you have any question or anything, you can call me on Friday. Okay.
Okay. Okay.
Or send the email. If you cannot get hold of me,
Okay.
call me at 318-278-2272. Okay?
So you said 318?
Yes. 278-2272.
Thank you.
Okay. I will see you on Friday.
Yes, sir.
All right. Take care.
Bye.
Bye-bye.